Okay, so I kind of left something out over here because, of course, I had an equal sign here and I didn't write what it was equal to. And it's equal to c cosine of omega t plus phi. Cosine of omega t plus phi by this identity is just cosine omega t sine cosine phi minus sine omega t sine phi. Okay, which makes things easier than trying to work it from the other side here, especially if I ignore the fact that there's a constant c here. Okay, and I changed my a that was here to a c because I've already used a over here, right? Okay, so I should have had a c in the denominator here, so that I have c's in the denominator here. The rest of it's true. Tangent of b is just this over this. C's divide out. You end up with this. You still end up with b. And the cosine of, well, it's going to turn out that b is your phase angle. Okay?
B is phi.
Yeah, we'll come to that from this point of view, though. Okay, so if you do this, this is more awkward, this is going to be more straightforward, but let's make sure we understand what we can about this, because it's an important type of manipulation. Okay, so B is the inverse tangent of this, and that works whatever A1 and B1 and A2 and B2 are. Okay? And then cosine squared B plus sine squared B equals 1, so the square of this plus the square of this has to equal 1. You just solve for C in terms of A1, B1, A2, and B2. Okay? Okay, so that can work. But this matches up much more easily. Okay? Because now that I write down what this is supposed to be equal to and that it's supposed to be equal to this, then I can pick a C and a phi that make this equal to this. Okay? So, if we want, do have the camera, okay. If we want the real part of this solution, if we want this to equal the real part of the general solution, then okay, looking at the real part, C cosine omega t cosine phi is the multiple you have of cosine omega t here, right? And that's here, okay, real part. A1 plus B1 cosine of omega t, because that's the only cosine of omega t you have here. In other words, A1 plus B1 has to equal C times the cosine of phi. And similarly, C sine of omega t sine phi equals negative A2 plus B2 sine of omega t. So C sine phi equals, I'll write it B2 minus A2. Okay? Now that's two simultaneous equations that can be solved. And it's parallels, you know, the more cumbersome solution I was into over there. Well, if I divide this equation by this one, get this, right? And okay? Because the square of this plus the square of this is c squared times the cosine squared plus the sine squared, right? And of course it's just the square of this plus the square of this. Now I just switch the sign of the B2 minus A2 since I'm squaring it. So I have AB, AB, 1, 2, right? Just the order looks better that way. Probably should have left it in that order throughout. So there we have pi. Okay. And we have C in terms of these arbitrary constants. Okay?
Okay.
Now, another quicker answer to your question. Yeah, we're just looking at the trigonometry things is going to help you. Okay?